Hello guys, in this video we are going to continue with integration by parts. In this video we are going to apply integration by parts in a not so obvious way. You know that integration by parts, it's applied when we have the product of two functions. Sometimes, of course. In this case, we are just going to apply this method to integrate natural logarithm of x and arctangent of x only. Okay, so if I ask you to integrate this, probably you think, okay, I see one function, but where is the other function? Okay, so this is what we are going to deal with today. And also, what are we going to need? So basic knowledge of integration, and for sure, since we are going to work with natural logarithm and arctangents, we need to know a little bit about these functions, okay? But just don't worry, it's not too much. Okay, let's start with the first slide, reviewing what is the integration by parts, okay? The idea is that you are going to have, look at this, an integral of two functions that multiply each other. One of the functions is going to be called u, and the other function is going to call dv. The one you call u, you are going to calculate its derivative as it's going to be differential of u. The part that you call dv is going to be integrated in order to get v, and then you replace here. Okay, so the idea is just to identify which one is going to be u and one is going to be dv. Okay, and then we integrate and calculate its derivative in order to apply this formula. Remember that this formula is very easy to obtain from the derivative of a product. Okay, it's not a really complicated formula. Come on, let's deal with an example. The integral of natural logarithm of x. Again, if someone asks me, this is okay, I don't know what should I do. Maybe a change of variable, maybe something different. Okay, it's a typical integral from integration by parts. I see two functions, and you are going to say, no, I see one. Yeah, you see one, logarithm of x. But you can think that logarithm of x is one function, and one, it's the other function missing. Okay, I can write this as natural logarithm of x times 1 times dx. Okay, so perfect. Which function is going to be u and which function is going to be dv? This is your choice, but if you choose not correctly, you are never going to reach any point. Okay, so in this case, if you choose the other way around, if you choose that 1 is u, then the derivative of u is going to be 0. So this doesn't make sense. But also it doesn't make sense if you just call dv the logarithm, because you are going to integrate logarithm. Oh, but this is exactly the same problem you have here. Okay, so in these cases, in these two examples, when you have natural logarithm of x and the arctangent, u should be always the function, the logarithm. Okay. So, if u is the natural logarithm, dv is just 1 times dx. Okay? Piece of cake. If you calculate the derivative of u, then it's the derivative of natural logarithm of x, that is 1 over x dx. If you integrate 1, the integral of 1 is x. So now you only need to replace u, v, and du in the formula. Remember the formula, okay? Now that I know what is u, what is v, what is differential of u, now I know what is these variables are, then I only need to replace. Okay? So this is u times v, x times logarithm of x. That is what I just wrote here. Minus the integral of v, x, differential of u, 1 over x. But that is very easy, because I need to integrate this, and what do you see here? X and x simplifies, and the only thing left is the integral of 1, and the integral of 1 is x again. So all of this is just x. So the integral, what is the integral? X times logarithm of x minus x plus the constant of integration. Piece of cake. But you need to apply this correctly, okay? The second example is the arctangent. This is exactly the same. I'm going to call u the arctangent. dv is going to be 1 times dx. This one is something I need to calculate its derivative. And probably you are thinking, oh, I don't remember what is the derivative of the arctangent. Okay, you should. It's important. Okay, it's important. The derivative of the arctangent is 1 over 1 plus x squared. Then, and the integral of 1, it's just x. Okay, I decided that u is going to be the arctangent, dv is going to be 1 times dx. I calculate the derivative of the arctangent, trust me, is that function, and the integral of 1, that is x. Now I can replace in the formula of integration by parts, that is v times u, so it's x times arctangent of x, minus v times du, so it's x times 1 over 1 plus x squared, and you obtain this formula, or this integral. Is this integral easy or not? Be careful. In this case, it's a quotient. The derivative of the denominator is on the numerator. The answer is yes. Okay, almost. I need a 2 to have the derivative of the denominator. But okay, adding a 2, it's very easy. If I add a 2 here, I need to put 1/2 in front of the integral. That is the reason that this 1/2 appears here. And what is the integral of 2x divided by 1 plus x squared? Is the natural logarithm of 1 plus x squared. Okay, so we have obtained a method to calculate the integral of the arctangent of x. Integral, that in any other way is going to be really difficult to solve. Okay? So we have applied the integration by parts in 2 specific cases, the natural logarithm of x and the arctangent of x. These are important and it appears many times, so please review the video as many times as you need or ask me if you have any questions. Thank you for your attention, guys.